Okay, starting a new chapter, chapter 14, and in 14.1 we get to graph sine, cosine, and tangent functions. If you look here, this is what a sine and cosine function looks like on an xy coordinate plane. One thing you have to keep in mind when you're graphing this on your graphing calculator, be sure that your mode on your graphing calculator is in radians. If it's not, it won't look like this kind of a loop, so to speak. But this loop is derived from the unit circle. So if you looked at, say, if you were to punch in your calculator the sine of 0, you would get 0. So that's where that dot comes from. And then the cosine of 0 would be 1. So that's another thing to kind of look for when it comes from the unit circle. And when graphing these things, we're looking for several different points that are going to help us determine how do we graph each function specifically. One of the things that we're going to look for is what is called the amplitude. And if we go down into our notes, we have two general equations for sine and cosine. We got y equals a times the sine of bx, and then we got y equals a times the cosine of bx. A is going to determine our amplitude for each of our functions. And so the distance from here to here is going to determine our amplitude. Next thing we want to look for is we're going to look for the period of each function. The period of each function is 2 pi divided by b, whatever b is. And then the ones on top of the graph, b equals 1, so the period of our function will be 2 pi. So that's the next thing we're going to look for. Another thing we're going to look for is what is called our minimum. And when you're dealing with cosine, if you look, the minimum value is right here. So you're only going to have one point in that period where there's going to be a minimum value. So the the coordinates is going to be 1/2 times it by whatever the period is. So it's 2 pi over b, comma, negative a. Now if I have the sine of a function, we're only going to have 1, and it's going to be 3/4 times the period, which is 2 pi over b, comma, negative a. So if I'm looking for the minimum, I'm also looking for maximum. So I got maximum value, and then for cosine, we actually have 2 points of a maximum distance for the period. We got one here, and we have one here. So it will be denoted as 0, comma a for the first one, and then the next one is going to be the period, which is 2 pi over b, comma a. And sine, we just have 1, which is going to be 1/4 times the period, comma a. And the last coordinates that I'm looking for is the x-intercepts. For sine, we have 3, 1, 2, 3, and then for cosine, we have 2, 1, and 2. And these coordinates are generalized as the x-intercepts right here. For cosine, there's going to be 2 of them, and one's going to be 1/4 times the period, comma 0. and the other one's going to be 3/4 times the period, comma 0. And then for sine, I said there was going to be 3 of them. The first one is the origin at 0, comma 0. The second one is at 1/2 times it by the period, comma 0. And then the last one is the period, 2 pi over b, comma 0. So those general equations are going to help us find the coordinates for our sine and cosine functions. So if I looked at example A, for instance, first thing I want to do is let's find what the amplitude is. So if I wanted to find the amplitude, I just look for what A is, and A happens to be 1. For B, I want to look for the period. And in the period, they're going to say it's 2 pi over B, and B in this case is 3. So the period is 2 pi over 3. If I'm looking for the minimum value of this function, I just resort to my sine of my minimum function, and it's going to be 3/4 times the period over by negative a. So if I look at that, it's going to be 6 over, what is it, 12? So that's going to be what, 1/2, so it's going to be pi over 2, comma, negative 1. And then the maximum for this particular one is we're going to have just the one coordinate because it's sine, and it's going to be 2 over 12, so it's going to be what, pi over 6, comma 1. And then the last thing is the x-intercepts. And for the x-intercepts, it's going to be, again, sine, so it's going to have 3 of them, so it's going to be 0, comma 0 for 1. The second one is going to be 1/2 the period, so it's going to be, what, pi over 3, because it's 2 over 6, comma 0. And then the last one's going to be the period, so it's going to be 2 pi over 3, comma 0. So this is what I'm more or less looking for when we're, even though they're asking to graph the function, I want you to find those 5 specific areas to help you graph each function. Okay? So if I looked at, say, example C here, again, I want to find those five specific areas. So I got A. The amplitude is going to be denoted as that value that's on the outside of the cosine, which is 3. And then for B, I want to find the period, so it's going to be 2 pi over B. Well, B is pi over 2. So if I look at this, this is going to be 2 pi over 1 multiplied by its reciprocal, which is 2 over pi. So the pi's cancel, which now my period is going to be 4. So if I go to C now, I'm going to find my minimum coordinate, and for cosine there is one minimum coordinate, and it's going to be 1/2 the period, so the period is 2, so half that's going to, or half, the period's 4, so half of that's going to be 2, and then it's going to be by negative a, and well, a is 3, so it's going to be negative 3. For the maximum, we're looking for 2 coordinates because it's cosine, and it's going to be 0, comma a, which is 3, and then the next one is going to be the period, comma a, which happens to be 4, comma 3, and then the last thing they want us to find is the x-intercepts. The x-intercepts for cosine, there are 2 of them, one of which is 1/4 times the period, so 1/4 times 4 is 1, comma 0. The next one is 3/4 times the period, so 3 divided by 4 times it by 4 gives me 3. comma 0. So those are the points for that particular function. Now when we look at tangent, tangent's a little bit different than sine and cosine. For one, it has no amplitude, which means it has no minimum or maximum value. The reason why it doesn't is because it has asymptotes. Asymptotes are what these little dotted lines are given to each of these functional graphs. And those asymptotes are where the function becomes undefined. It becomes undefined because from what we learned in chapter 13 about the unit circle, there's some areas where you can't find the values of those functions because you're going to divide the ratio by 0, and you can't do that. That's where we get the undefined functions in our graph. Another thing that's different is that the period occurs from both the positive and the negative value of our graph. So what we're looking for is this. Just like what we were looking for in our points for sine and cosine, we're going to do the same thing with tangent, but we're going to use a little bit different. First off, I want to find out what my A and B are. My A, like say for example, A is going to be A equals 2, and my B is going to equal 1/2. The first thing I want to find is I want to find what the period is for this function. So the period denoted for tangent is, the formula is going to be pi over b. So if I'm looking at this one, I'm going to have pi over 1/2. So now this is going to be 2 pi. So my period is 2 pi. For b, I'm looking for the asymptotes of my function, at least for the period of the function. And you're going to have two of them, and it's denoted as the general equation of x equals, because it's a vertical line, and it's going to be pi over 2b, and also it's going to be x equals negative pi over 2b. So for this particular equation, we're going to have x equals pi over 2 times 2 pi, which is going to give me 1 over 4, and it's going to be x equals negative 1 over 4. The next thing I want to find is my halfway points. And my halfway points here, if I were to get a graph here, looks something kind of like this. The halfway point is the point in between the period that is in between the x-intercept and our vertical asymptotes. And those are denoted as in the formula of pi over 4b, comma, a, and also negative pi over 4b, comma, negative a. So looking at this particular one, where y equals 2 times the tangent of 1/2 x, if I use the coordinates here, it's going to be pi over 4 times 2 pi. Well, the pi's cancel, so it's going to have 1 over 8, comma, a, and a is 2. And then the next one's going to be negative 1/8, comma, negative 2. Last thing I have is d, which is our x-intercept. And that is, in this particular period here to here, is just one spot, and that is 0, comma, 0. Okay? Let's take a look at b, for instance. So knowing what we have here for y equals 4 times the tangent of 2x, I got a equaling 4, and I got b equaling 2. So let's take a look at this one. So the first thing I want to find is the period. The period is pi over b. So my period is going to be pi over 2. The next thing I want to find is my vertical asymptote. So it's going to be x equals pi over 2b. So it's going to be pi over 4. Or x equals pi over 4. And also x is going to equal negative pi over 4. For c, I want to find the halfway points. And so the coordinates, first one's going to be pi over 4b. Well, b is 2, so it's going to be pi over 8, comma a. Well, a is 4. And the next one's going to be negative 8, comma negative 4. And then the last thing for d is the x-intercept, and just like the rest of them, as long as there's no translations, it's going to be at 0, comma 0. And that is being able to graph and identify specific points in sine, cosine, and tangent functions. Hope this helps. Until next time.